not a lot of choice on your u here. It's pretty obvious that our u is going to have to be 4x plus 2. And so when we find du, it's going to be 4 dx. Everything is looking pretty good. So let's rewrite this as the antiderivative, or the integral of tangent u, because this is u right here. But remember, you can't just put dx. You've got to fix this 4 dx. So I'm going to multiply dx by 4, which means I have to multiply out front by 1/4. You can multiply inside or outside, but outside seems to keep it out of the way. Now this 4 dx can become the du right here, and I'm ready to find the antiderivative. Or am I ready to find the antiderivative? Is there anything that you can take the derivative of and you end up with tangent? And if you look at your list and you rack your brain, you will realize that there is nothing. So this is trig, and for trig we have nifty little substitutions that we can make. Please don't say 1 over cotangent. The tangent is sine over cosine. The 1 over cotangent is not going to help you at all. Now I'm going to have to do another substitution. I've already used the letter u, so I need to pick a different letter. And you can pick any letter you want. I'll use v. I need to choose either sine u or cosine u to be the v. Now the safest place to start is to choose the denominator, because usually when I choose a function that's not a fraction and then I find the derivative is usually not going to be a fraction either. And so I want to try to make my substitutions in the top of the fraction. So I choose the bottom of the fraction to be my v. So I have cosine u for v. So dv du is equal to negative sine u du. And now I'm ready to make a substitution from u's to v's. Keep in mind you got to keep this 1/4 out front. I've got sine u du right here, and I've got negative sine u du right here, which I want to substitute dv for. The only thing missing is the negative sign. So I put a negative sign on the inside, multiplying by a negative. I need a negative sign on the outside so that I'm not changing the value of anything. All right, so now I'm ready to substitute. Negative sine u du is now dv. You can write it out to the side, or you can write it in the top of the fraction. And then what I have here is 1 over v, because remember cosine u is what I chose for v. You could also write this as v to the negative 1, either way. But you should recognize that this is the power that power rule does not work on. So I have negative 1/4. The antiderivative of 1 over v, or v to the negative 1, is going to involve the natural log, absolute value of v, and then plus c. So that wasn't too bad, even though it took 2 substitutions. Keep in mind that I do need to take this back to x's. I don't want to leave it in terms of v. But we can backtrack pretty quickly. Negative 1/4 ln absolute value. Instead of v, I want to substitute cosine u. So here's my cosine. But instead of u, I lost that. Instead of u, I want to substitute 4x plus 2. Close your absolute value, and then plus c. The reason we have to use the absolute value on the logarithm antiderivative is because it's a domain issue. Logarithms go like this. Only positive x values are in the domain. And there's a possibility that this v, which is cosine u, there's a possibility that that value could be negative. So that's what the absolute value symbol does. If that value happens to be negative, then it will automatically change it to a positive, and everything works great.